Welcome to Precalculus Algebra, finding the equations of shifted conics. So before we get started, we're going to need to recall what's called the midpoint formula. So if you have 2 points, here's the first point with its coordinates, and here's the second point with its coordinates. If you want to know the coordinates of the midpoint, all you do is you add up the x-coordinates, divide by 2 to find the new x-coordinate, or the x-coordinate of the midpoint. And to find the y-coordinate of the midpoint, all you do is add the y-coordinates of the 2 points and then divide by 2 as well. So you're basically averaging the coordinates to find the coordinates of the midpoint. Okay, with that in mind, let's go ahead and find the equations of shifted conics. By the way, we should point out here that we're just shifting our conics vertically and horizontally. We're not rotating or anything like that. Okay, so let's take an example. So let's find the equation of the ellipse with vertices -1, -4, -1, 6, and foci -1, -3, -1, 5. So we have to first of all decide if our ellipse is orientated with the major axis going horizontal, or if the major axis is going vertically. And the key, of course, is noting that or remembering that if it was oriented like this, right? All the vertices, right, the vertex here, the vertex there, and the vertex there, and the foci, they're all located along the major axis. So if the ellipse was oriented like this, rather, the foci and the vertices would all have the same y-coordinate, right, because they're along the same horizontal line. But if it's oriented like this, they'd all have the same x-coordinate. So when I look at these ordered pairs, I see that they all have the same x-coordinate. So our ellipse must be oriented with the major axis vertical. And so this is the equation of the ellipse that's been unshifted when the major axis is vertical. So what we're basically going to want is this equation, but accounting for shifts as well. Okay, so let's do that on the next page. But the important difference between these two, of course, is where A resides. So A is larger than B, and if A occurs under Y, like it does here, the y-coordinate, that means it's oriented vertically. But if A occurs under X, that means it's oriented horizontally. Okay, so in this case, for our purposes, for this ellipse, that the information we're given here, the A is going to be under Y. Okay, so with that in mind, let's go forth. So this is the information we have. These are the vertices, and these are the foci, and our ellipse looks like this. Now, to account for shifts, we're going to write the ellipse in the following form. We're going to write y minus k over y minus k squared divided by a squared plus x minus h squared divided by b squared is equal to 1. So all we're doing here is acknowledging that the ellipse is, every point on the ellipse is shifted, and if we account for the center being shifted, that will account for the whole ellipse being shifted. So the y minus k and x minus h, the h comma k account for how far everything is shifted horizontally and vertically. Okay, so now remember what we said about midpoints. The center, of course, is halfway. It's not on the ellipse, but it's halfway between the vertices, and it's also halfway between the foci, which reside within the ellipse. So we can find the center by taking the midpoint of these 2 points, right? Because you have a vertex here and a vertex there, and the center of the ellipse lies between those 2 points. So the midpoint, that is the center, we're going to take by averaging the x-coordinate. So it's going to be, let's write -1, right? I take this x-coordinate and I add it to that one. So -1 plus -1. And then I divide that by 2. And then I do the same thing with the y-coordinates. -4 plus 6, and I divide that by 2. And I'm looking at -2 divided by 2, so -1, and then the y-coordinate of the center is now going to be 2 divided by 2, which is 1. So this is my new center. Now it also tells you that everything's been shifted in that way, right? Everything's been shifted 1 to the left, because the -1 tells you that it used to be 0, 0, but now it's -1, 1. So the shift has been to the left and then 1 up. So here, when I write, when I account for the shift here, my k is going to be -1. Sorry, my k is going to be +1, right? Because it used to be 0. And then my h is going to be -1, this number there. So I can write that in now. I'm looking at y minus 1 quantity squared divided by a squared, plus it's going to be x minus -1. So x minus -1 quantity squared over b squared is equal to 1. Okay, and so we'll write that as just y minus 1 squared over a squared plus x plus 1 quantity squared b squared is equal to 1. Okay, so now we've got to find the a and the b. Now remember that the distance from the vertex to the origin, right there, that's a. And then the distance from, the foci, right there, that length right there, that's c. So there are a couple of ways of doing this. One way is to acknowledge that that what you can do is simply find the length of the major axis by subtracting the y-coordinates of the foci and then dividing by 2. So that it's the length of the major axis, which in this case runs vertically, the length of that's going to be, well, the y-coordinate way up there, take away the y-coordinate down here, and then divide that by 2. So this is 6, right, way up here, the y-coordinate, according to this, and then this y-coordinate is going to be -4. So I take 6 take away -4, so I'm looking at 6 take away -4, and then I divide that by, well, that's the length, which is 10. So this whole length is going to be 10, but then if I divide that in 2 to get a, I get 5. So a is half of the length of the major axis. So we've got a is equal to 5. Let's write that here. So a squared is going to be 25. Now we can also do the same thing to get c, right? Because we know the foci, right? We're looking at one of the foci having a coordinate of 5 up here, and the one below it having a coordinate of -3. And that length is going to be 8, right? 5 take away -3 on the y-axis. And then when you divide by 2, you get c, which is going to be 4. So the distance from the center to the foci, that's what c is, right? So the distance between the foci is 8. Let's write that down. Distance between the foci. I found that to be 5 take away -3. And I got 8. But that means half that distance, which is c, is 4. So let's go ahead and, well, oh, by the way, we have a and we have c, but c doesn't show up explicitly in this equation. Now remember, of course, that b squared, let's write that maybe here, a little more room. B squared is always a squared take away c squared. So in this case, b squared is going to be, a squared is going to be 25, and then c squared is going to be 16. So b squared is going to be 9. And that's the length, b is the length of the b is the length of the minor axis, which is 3. So b would be, b is, or sorry, 2b is the length of the minor axis. So this distance from the length from here to here is just, is b, and that's 3. But anyway, our equation is going to be this. Y minus 1 quantity squared over a squared, which is 25, plus x plus 1 quantity squared over b squared, which is 9, is equal to 1. So this is the equation of the ellipse with the given information. Now, of course, you can shift parabolas and hyperbolas as well. Let's see examples of those now. So let's find the equation of the parabola with the focus of 1, 3 and the directrix of x equals 3. And just like before, you have to decide which case you're in. Is your directrix horizontal or is your directrix vertical? Well, here we're given that the directrix is x equals 3, so it's a vertical line. So we're in this case here, right? Now, when I say this case, notice that our parabola here, I drew it opening right, but we can also have a parabola opening left with a vertical directrix. So we don't know yet, just upon that consideration, what we've got here. But we know that we've got a vertical directrix. So once again, we'll take this, which is the unshifted. This equation is a parabola but unshifted, and we'll take this and we'll make the adjustments for a shifted parabola. Let's do that on the next page. So we've got y squared, we said, equals 4px. And I drew in here the fact that our focus is at 1, 3. And so this is our focus, and then here's our directrix. Now remember, a parabola always opens towards the focus. So the parabola must be like this. And of course, the vertex of the parabola lies between the focus and the directrix, and it opens towards the focus. So our parabola must look like, that's not the best looking parabola I've ever drawn, but something like that, right? It's opening to the left. Now, when a parabola opens to the left, that tells you that p is less than 0. So we keep that in mind here. Now our equation is going to be this. Y minus k, just like before, squared equals 4p times x minus h. So you basically replace x with x minus h and y with y minus k to account for horizontal and vertical shifts. Okay, and of course we have to find h, k, and p. So the easy part is p. First of all, p is less than 0. And remember, p is the distance from the vertex. The absolute value of p, rather, is the distance from the vertex to the focus. So that distance is 1, but we know p is less than 0, so the p must be -1. So we can write that in. That we've got y minus k squared equals 4 times -1 times x minus h. So we're looking at y minus k squared equals -4 times x minus h. And then finally, where would the center be? Well, we can see that, remember, the parabola is opening to the left, but the vertex, right, that has the same y coordinate as the focus. So the vertex has a y coordinate of 3, and we talked earlier that the x coordinate, this point lies between the focus and the directrix. So the x coordinate, because that's 1, and this x coordinate is 3, the x coordinate of the vertex must be 2. So the vertex has been shifted right 2 units and up 3 units. So in this case, h is going to be 2 and k is going to be 3. So we've got y minus 3 squared equals -4 times x minus h. That is x minus 2. So we've got a shift of 2 to the right and 3 up. And this would be it. That would be the equation of our shifted parabola, given that information. All right, let's see an example now for hyperbolas. So let's find the equation of the hyperbola with foci 1, -5. So here's one of the foci, and then 1, +5. That passes through the point 1, 4. So the hyperbola goes through this point right here. Now you can see where the foci are. That, remember, a hyperbola either opens left and right, that is, the branches look like this, or the hyperbola opens up and down, so like that. Now, of course, the foci and the vertices lie along either a horizontal axis or a vertical axis. So in this case, I can see that everything's lying along a vertical axis, so I must be in this case right here, right? I must have branches opening up and down. And it goes through the point 1, 4. So my hyperbola is going to look something like this, right? Just drawing it in like that. The foci are not on the hyperbola. Only the vertices. So this would be -4. It'll look like this. So my hyperbola is looking something like that. Now, just like before, you want to find the center, right? Just like with ellipses. So the center, you can find, the center lies between the foci. So to find the center, you can take the average of the x-coordinates and the average of the y-coordinates. So you add the coordinates together, and then divide by 2. So it's going to be 1 + 1 over 2. And then adding the y-coordinates, 5 plus -5, divided by 2. And so this would give 2 over 2, which is 1, 0 over 2, which is 0. So my hyperbola has been shifted to the right 1 unit, but it hasn't been shifted up or down. So there's only a a horizontal shift. Now, because it's oriented vertically, remember that the a goes under the y coordinate. So in this case, we've got y squared. Take that back. It's been shifted. So it's going to be y minus k squared, like it is for all the other ones. So y minus k squared over a squared minus x minus h squared over b squared equals 1. And it's minus here because it's a hyperbola. So we said that there was that k is 0 and h is 1. So we're looking at just y squared. Let me write it in so you can see it. Y minus 0 squared over a squared, and then minus x minus 1 squared over b squared equals 1. So we've got, so far, y squared over a squared minus x minus 1 squared over b squared equals 1. And now it's time to find a and b. Now we can do that by making use of the fact that this point is on the hyperbola. So I can plug in that point, 1, 4, and what happens when I do that, right? This point satisfies that equation. So when y is 4, this becomes 16 over a squared. And then when x is 1, this is 0. So minus 0 equals 1. And that tells me if I solve that equation, 16 over a squared equals 1, that a squared must be 16. So I've got my a squared. Now the question is, what about my b squared? Now remember, the foci, of course, is just like before. It's the distance from the center to the c is the distance from the center to the foci, to one of the focuses. So in this case, it's going to be, you can just tell it's 5, right? Because the center is 0. Another way to do it, of course, is just figure out the length between the two. 5 take away negative 5 is 10, and take half of that, and you've got 5. So that means my c is equal to 5. That is the distance from the center to the focus, to one of the foci. And that means my b squared, which I get by taking c. Now, b squared is, in this case, for a hyperbola, it's c squared take away a squared. With an ellipse, they're reversed, right? It's a squared take away c squared. But for a hyperbola, it's c squared take away a squared. So b squared is going to be c squared, which is 25, take away a squared, which is 16. So b squared is equal to 9. So my equation is going to be, I know my a squared, I know my b squared, so my equation is going to be y squared over 16 take away x minus 1 squared over b squared, which is 9, is equal to 1. So 9. Okay, now that'd be my equation. Okay, so that's how we find equations of shifted conics. Until next time.